Okay, let's have a look at example 4, all right? We've got 2 cos 6x times by cos 4x, and then it's minus cos 10x plus 2 sine squared x, and we're trying to get this whole left-hand side to land up equaling 1, okay? So we'll get there, all right? We will get there. We've just got to figure it out for now. So there's a few little tricks that I do want to point out to you over here. Can you see that we've got an angle of a 6x and a 4x over there, okay? Now, and then we've got this 10x over here. Now, remember that if you're wanting to apply any kind of double angle or compound angle identity, you need those angles to match each other, all right? So it's not going to help you to leave it as 10x. So if you look at 10x, okay, the best thing for me to do with that is to actually split it and to create a compound angle with it, obviously splitting it into a 6x plus a 4x because that's giving you 10. Can you see that that's going to work for you because then it's going to match your 6x and your 4x, okay? So that's going to be the first thing you need to do here. So we've got our cos 6x times by your cos 4x, and you've got minus cos, and as I say, instead of working with 10x, split it and write it as 6x plus 4x, and then at the end there we've got this 2 sine squared x, which, you know, sine squared x does have an identity. Don't get too excited about jumping into using all the identities for now. Just hang on to it. We might change it, but let's just take it one step at a time here. Let's deal with this now. So we've now created a double angle identity over there. And I think the best thing to obviously do with that now is to stretch it out. Okay, so let's see if we can do that. We've got I've got cos x, cos 6x, cos 4x, minus, now can you see I'm putting this in a bracket because the negative belongs to the whole expression, your whole double angle, okay? And remember, your double angles are going to be cos, C for cos, C4, change that sign, and then it's sine, okay, right? And then we're still sitting with, okay, I'm just going to have to squeeze it underneath here. We're still sitting with that 2 sine squared x, which, as I said, for now, I'm just hanging on to. I'll deal with it when I'm ready. Okay. Right, so what do we have over here now? I've got a 2 cos 6x 4x, cos 4x. The negative is now going to distribute into a bracket. So we've got negative cos 6x cos 4x. A negative and a negative are becoming positive. We've got sine 6x sine 4x. Sorry, that was supposed to be a 4x, so let's just correct that. All right, so sine 6x sine 4x, and then again, as we said, we've got this 2 sine squared x over here. All right, so look for like terms. I think that's probably our best bet over here. So I've got a cos 6x cos 4x over here, and I've got another cos 6x cos 4x over here. So do you agree I do have like terms? And if you've got 2 cos x minus 1, 2 minus 1 is leaving you with just 1 cos 6x cos 4x as the solution to those two subtracted from each other. Then you still have your sine 6x sine 4x, and you've got this 2 sine squared x sitting at the end over there. Okay, all right, cos sine, and I've got this 2 sine squared x over there. What am I going to do with that now? So let's deal with this identity. Let's deal with that compound identity over there now. Okay, we can see that I've got an angle of 6x matching my angle of 6x. I've got 4x matching 4x, and I've got the cos together and the sine together. So we have got a cos compound angle, which means I'm going to say 6x, but remember C for cos, C for change the sign. All right, so let's see where that takes us. Okay, so 6x minus 4x is cos 2x plus 2 sine squared x. Okay, so now I'm sitting with a double angle identity that I would be able to expand, okay? And remember, there's three possible identities, but because we've got a sine squared x over there, it kind of pushes me in the direction of using the identity 1 minus 2 sine squared x, and then you've got this plus 2 sine squared x. And look what happens. Minus 2 sine squared x plus 2 sine squared x, they cancel each other out, and we're left with 1. Okay, who would have thought? So all of that simplifies down to just your value of 1. So remember, our final statement there is that our left-hand side is equal to the right-hand side. Okay. Go back and watch the video again. Just go and see carefully how one step at a time we process that all the way down to a value of just 1, okay? And don't get overwhelmed in a test. If you're feeling like you're kind of just going in circles a little bit, obviously you don't want to spend too long going in circles, but you do find that if you're just slowly unraveling the equation one step at a time, and sticking to rules and just being careful about that, you actually do get there, okay? So this is a nice example of, it took a bit of time, but we got there. So well done.